So in this unit, we are going to need to make sure that we can solve quadratic equations by factoring and also by using the quadratic formula. So let's use the quadratic formula here. So we end up with x equals negative of negative 4 plus minus negative 4 squared minus 4 times a times c. Okay, and that's all over 2a. So then simplifying this, we end up with 4 plus minus. Okay, this ends up being 24, so plus 24, so we end up with 16 plus 24 is root 40 over 4. Simplify this, we have a common factor of 4 here, so outside it becomes 2 root 10. Okay, and then in reduced form, we have to reduce this fraction by a factor of 2. So we end up with 2 plus minus root 10 over 2. Okay, before we can use quadratic formula here, we need to expand the brackets and make it equal to 0. Once we have that, we can plug it into our quadratic formula. So we get negative b plus minus square root of b squared minus 4 times a times c all over 2 times a. Okay, so this ends up being negative 48. So 4 minus negative 48 is 52 all over 8. There's a common factor of 4 involved here, so we have to make sure we take that out. So we end up with 2 square root 13 all over 8, and then simplifying this fraction, we end up with negative 1 plus minus square root 13 all over 8. Okay, so that would be the simplified version of that. So we want to solve this by factoring. Solving these equations by factoring, we need to break down this cubic function. So let's try using 1. Okay, it looks like 1 will work, so we end up with 3 plus 5 minus 4 equals 0. So I know that x minus 1 represents one of my factors. Okay, so I'm going to go x minus 1 here. I have a quadratic then that I can break this down into. Using division, I'm going to break this down into its quadratic form. So make sure that you have a placeholder for every power of x. In this case, we have coefficients on every x. So we're going to do times and then subtract. Times, sorry, this is going to be negative. So it's going to be 5 minus negative 3 is positive 8. Okay, so it's going to be negative 8. Negative 4 minus negative 8 is going to give us positive 4. So we end up with remainder of 0. So my quadratic term is 3x squared plus 8x plus 4. Okay, so that's going to be my quadratic. I still need to factor that. So the quadratic terms is 3x squared plus 8x plus 4. Okay, to factor that, I'm just going to use my little box. So we know that the diagonal product of 12x squared is equal to the sum of these have to equal that same diagonal product. So I get 6x and 2x. So factoring this, I get 3x plus 2. And then we have x, common factor vertically here is 2. So we end up with x plus 2, 3x plus 2. So those are my factors involved. So I end up with x plus 2, 3x plus 2 as my quadratic factors up here. Okay, just going to move this down a little bit. Now, I factored this, but we're actually asked to solve this. So make sure that you answer the question and actually solve this equation. So this is my equation. the solution to this is going to be x equals 1, x equals negative 2, and x equals negative 2/3. Okay, so we actually have to make sure we answer the question. It is an equation, it doesn't just say factor, so we need to solve that. So we'll do the same thing here. We're going to need to, it's a cubic function, so we need to guess the first solution. We're going to guess the first solution, and then break down the quadratic to quadratic. So I'm going to, looks like I can see if I plug in 3 in here, it'll work. So I'm going to end up with 27 minus 27 plus 3 minus 3. Okay, so we're going to get 0 here, so my factor here is x minus 3. Okay, we want to break this down into its quadratic, so I'm going to do my division. So 1, negative 3, 1, negative 3. I'll use my negative 3 factor here. Okay, again, remember that you have to get a remainder of 0, otherwise something's gone wrong. So this quadratic is x squared plus 1. So here I get x squared plus 1 as my quadratic factor. Now this is being asked to, I can't factor that, and we have to say, is this an irrational or non-real root? Well, if I look at that, I can kind of tell it's a non-real root. We can try using the quadratic formula, but you'll see that you're going to end up with a negative discriminant. So here we factored, this is as far as I can factor. And again, it's an equation, so I need to solve. So I need to actually solve this equation. And the solution to this is x equals 3, and that's it. Okay, it has no real roots. So what might this graph look like? Well, we don't exactly know where the non-real roots are, but we know that it has a real solution at x equals 3. So it's going to go through there. And it has to have some non-real part somewhere. Now it could look like this, we don't know. It could, look like this, go through here like that, have the non-real roots there, we don't know. Okay, so I'm just going to leave it like that. But the non-real solutions will show up somewhere in the graph as a bump that does not cross the 0.